there emerged strange anomalies within its operation. Insiders described perplexing calculations that defied comprehension, while engineers were running highly complex computations. They began encountering unexplained glitches, which were eventually recognized as patterns that resembled something akin to ancient hieroglyphics. Have you ever wondered about the origin of aliens, ghosts, or demons? Have you ever asked your priest or pastor if the Bible can explain these things, only to come away with no real answers? Well, I don't know about you, but I have, so I've spent 15 years researching these topics, and I've come away with a very compelling explanation for many of the world's mysteries. I'd like to start a conversation about the things your pastor is afraid to talk about. This is Audra Moore, and you're listening to Evil's Ancient Origins. In my previous episode titled How Do Quantum Computers Work? Exploring Quantum Mechanics and Spirituality, I gave you a basic foundation which we are about to build upon. In this episode, I want to focus more on Google's Willow quantum processor. So, if you're seeing my channel for the first time, or if you just missed the last episode, check out my previous installment of Evil's Ancient Origins to brush up on some of the basics of quantum computing. In the meantime, I'm going to do my best to thoroughly explain the topics I'm covering today. So, without further ado, let's jump in. I know, quantum computing is a unique topic. In case you didn't know, there are multiple corporations as well as governments around the world who are racing to be the first to invent a commercially viable quantum computer. And they've been working on this for over a decade, at the very least. Now, in 2019, Google announced that with their Sycamore quantum processor, they had achieved quantum supremacy. This refers to the point where a quantum computer demonstrates the capability to solve a specific computational problem, which is too hard for even the most powerful classical computers to deal with in a timely manner. The problems they use to demonstrate this supremacy are specifically designed to be mathematically difficult or outright impossible for a classical computer to solve. Although it doesn't necessarily mean that quantum computers will replace classical computers in all computational applications, this is a significant demonstration of quantum computing's dominance regarding certain types of calculations. Quantum supremacy is a significant milestone, but it is primarily just a scientific goal at this stage and doesn't necessarily translate to immediate practical benefits or commercial usability. Due to their quantum nature, a quantum computer is vulnerable to the tiniest atmospheric disturbance. Therefore, they must be isolated, contained in a completely solitary state to avoid the observer effect from disrupting their calculations. To do this, the system is encased in a vacuum chamber and subjected to temperatures magnitudes below freezing, as an attempt to prevent decoherence, the conditions where the qubit loses its state of superposition. According to Google's research blog, quantum information is delicate, and even state-of-the-art quantum devices will typically experience at least one failure in every 1,000 operations. In order to manage these failures, quantum error correction, or QEC, is implemented. So, these QEC techniques are used in quantum computing to protect quantum information from errors due to decoherence and other quantum noise. Wikipedia goes on to say that quantum error correction is theorized as essential to achieve fault-tolerant quantum computing that can reduce the effects of noise on stored quantum information, faulty quantum gates, faulty quantum state preparation, and faulty measurements. In quantum computing, gates are the fundamental operations that manipulate the state of the qubits. They are analogous to logic gates in classical computing, but they operate on quantum bits, which can exist in superposition. Remember, a 0 and a 1, where classical bits are either a 0 or a 1. Now, according to Wikipedia, classical error correction often employs redundancy or repetition codes. This is the simplest and most basic approach to error correction. You see, in order to transmit a message over a noisy channel, which may corrupt the transmission, a repetition code is transmitted. The intent of the repetition code is to repeat the message several times with the hope that the channel corrupts only small parts of these repetitions. The code stores the desired information as multiple copies, and if these copies are later found to disagree due to errors introduced to the system, it then determines the most likely value for the original data by a majority vote. This technique is used throughout the industry. So, Google's search engine AI explains it like this. Quantum error correction works by encoding quantum information across multiple physical qubits to create a logical qubit. This redundancy allows the system to detect and correct errors without losing the original quantum information. The Willow processor was designed and tested with advanced quantum error correction techniques, including using larger arrays of physical qubits to create logical qubits, a form of redundancy error correction. The experiments that were run with Willow showed that as the size of the physical qubit arrays increased, the error rates decreased exponentially, demonstrating below threshold error correction. They claim that this is a key step towards building larger, fault-tolerant quantum computers because Willow's error correction method actually improved the overall system performance as more qubits were added. This means that even as the complexity of the calculations increased, the error rates were still being reduced, indicating the effectiveness of the error correction methods. I'm getting to something here, so just bear with me. So, Google claims that the more qubits they use in their processor, the more they reduce errors, and the more quantum the system becomes. It's also one of the first compelling examples of real-time error correction on a superconducting quantum system, which is crucial for any useful computation, because if you can't correct errors fast enough, they ruin your computation before it's done. And, they continued, it's a beyond break-even demonstration where our arrays of qubits have longer lifetimes than the individual physical qubits do, an unfakeable sign that error correction is improving the system overall. This is interpreted to mean that as they increase the amount of bits that are in a quantum state, which is the definition of a qubit, then the less errors they produce during their calculations. And as a reference, a qubit or quantum bit is in theory entangled with another dimension, where the calculation process is shared across the entangled dimensions. So we're talking multiple dimensions calculating at the same time to come up with the answer. So they're saying that the more qubits there are, the more interdimensional calculations can occur and the fewer errors they will encounter. In effect, the more bits coupled with other dimensions, there is a deepening of the connection in the quantum realm, sort of like strengthening the quantum signal. And this better connection means there will be less distortion in the transmission. It almost seems like they're describing using a walkie-talkie or a CB radio to communicate with other dimensions. I mean, quantum computing reminds me of an overly complex spirit box. Now, in case you're unfamiliar, Wikipedia states that the spirit box, also known as the ghost box or Frank's box, is a device used in paranormal investigation to attempt to communicate with spirits. Invented in 2002 by Frank Sumption, it is a modified AM radio receiver that sweeps through the radio waves, capturing snippets of sound, which is thought to allow spirits to communicate through the noise. Frank Sumption claims that he received the design instructions from spirits. So let me describe for you what it sounds like. It's like sentences being pieced together with individual words being chosen as it sweeps through each of the channels. Like the entity is picking and choosing each word until a coherent sentence is produced. And it's pretty impressive. I mean, it's pretty bizarre. The TV show Ghost Adventures is credited with popularizing them on television, but spirit boxes are commonly used within the realm of paranormal investigation. They're closely associated with the concept of EVP, or electronic voice phenomena, another tool used within that arena. Wikipedia explains that electronic voice phenomena are sounds found on electronic recordings that are interpreted as spirit voices. So, a parapsychologist who popularized the idea in the 1970s described EVP as typically more brief than what a spirit box will produce, usually the length of a word or a short phrase. Enthusiasts consider EVP to be a form of paranormal phenomenon, often found in recordings with static or other background noise. But again, according to Wikipedia, this concept is really nothing new. It states that as the spiritualist religious movement became prominent in the 1840s and on through the 1940s with a distinguishing belief that the spirits of the dead can be contacted by mediums, new technology of the era, including photography and other things, were employed by spiritualists in an effort to demonstrate contact with a spirit world. So popular were such ideas that Thomas Edison was asked in an interview with Scientific American to comment on the possibility of using his inventions to communicate with spirits. He replied that if the spirits were only capable of subtle influences, a sensitive recording device would provide a better chance of spirit communication rather than the table tipping and Ouija boards that mediums employed at the time. I mean, imagine, if you will, that top scientists around the world are currently essentially developing their own quantum spirit box with the intention of communicating with other realms. Someone, please tell me what the difference is here. If you feel like I'm just being dramatic, listen to what happened next. As Google was ramping up testing of their new rendition of a quantum processor, Willow, they excitedly claimed that it was able to carry out a computation in under 5 minutes that would have taken the fastest existing supercomputer longer than the current age of the universe to complete. However, there emerged strange anomalies within its operation. Insiders described perplexing calculations that defied comprehension. While engineers were running highly complex computations, they began encountering unexplained glitches, which were eventually recognized as patterns that resembled something akin to ancient hieroglyphics. According to the YouTube channel Top Master, in their video titled Ethical Hacker, the real reason why Google has just shut down their quantum chip, they state that in the middle of groundbreaking successes, certain data sets began producing results engineers couldn't explain. Insiders claim that at first they encountered what appeared to be misfires, if you will. The computational outputs included repeating geometric patterns reminiscent of mandalas, labyrinths, and symbols which were eerily similar to those of ancient Mesopotamian or Mayan cultures. To the untrained eye, it looked like a malfunction, but to those paying attention, these anomalies repeated with unsettling consistency. The anomalous outputs, nicknamed glyphs by the engineers, grew more frequent over time. Even stranger, the complexity of the symbols escalated, with each experiment suggesting they weren't random noise. Some researchers joked nervously about the ghost in the quantum machine, and others, however, weren't laughing. Apparently, specialists were brought in to interpret the data, but this only generated more unanswered questions. The video goes on to say that a key sticking point was the consistency of the glyphs. In quantum computing, errors due to interference or environmental instability typically yield unstructured junk data. But what Willow produced was organized. Theories included that they were some sort of quantum language or a self-generated computational output produced through the quantum process. The most disturbing theory is that of quantum consciousness. They say that theories about parallel dimensions, simulation, or even precursors of intelligence were explored. A team of linguists who were brought in to consult on the project combed through archives of historical and archaeological records and found unmistakable similarities between Willow's glyphs and symbols found in ancient civilizations, including Sumerian cuneiform, Egyptian hieroglyphs, Chinese oracle bone scripts, and Nordic runes. The specialists stated that they weren't exact matches, but bore enough resemblance to stir debate. Some argued that this was only an instance of pareidolia, which are moments where the human brain, trying to make sense of something, begins to recognize semblances that don't actually exist. Sure, repeating complex patterns resembling ancient writings are all in your imagination. It's all just junk data. To me, this is evidence that there truly is a proverbial ghost in the machine. No, not proverbial, an actual ghost in the machine. Now, at this point, I'd like to recognize the department within Google that is developing these quantum processors. It is their Quantum Artificial Intelligence Lab. which is spearheaded by Google's Vice President of Engineering and founder of their quantum AI lab, a person named Hartmut Neven. Neven is pictured here attending the invitation-only Further Future Festival that was held in 2016. It was touted by The Guardian as being the Burning Man for the 1%, the desert party for the tech elite. The article's caption states, "Further Future is the tech-centric, unapologetically luxurious alternative to Burning Man, complete with personal assistance, spa treatments, and fine dining." It goes on to explain that the event is more of a networking opportunity for the tech world's best of the best to rub elbows with executives of the most sought-after tech companies. According to their website, the objective of the Google Quantum AI Lab is to fabricate quantum processors and develop novel quantum algorithms to dramatically accelerate computational tasks for machine intelligence. Previously, Hartmut was head of the visual search team. His team developed the visual search service, which today is used by a large number of Google products, including image search, Google Photo, YouTube, Street View, and Google Goggles. Neven coined the term quantum machine learning and quantum AI and implemented the first machine learning and image recognition algorithms on a quantum computer in 2007. His teams were the first to physically instantiate time crystals, non-abelian anyons, and traversable wormholes using a quantum processor. And for your information, time crystals are a quantum system of particles whose lowest energy state is one in which the particles are in repetitive motion. I just had to look that one up. I mean, he sounds like the Time Lord himself, or maybe a villain from within the Doctor Who universe. I'm just joking. Okay. I'm not trying to make any enemies here. He is obviously a very intelligent person, and I truly respect his veracity to pursue the investigation of cutting-edge science. Anyway, quantum computing and AI seem to have a symbiotic relationship where each technology enhances the other. According to Google Search AI, quantum computing can potentially accelerate AI algorithms, process vast amounts of data, and explore a wide range of possibilities, potentially leading to faster and more efficient AI models. So, quantum computers can help AI systems learn and make decisions faster and more accurately, leading to better performance in areas like image recognition, natural language processing, and robotics. Conversely, they claim that AI can help optimize quantum algorithms, improve quantum hardware, and develop new applications for quantum computing. AI can also be used to simulate quantum systems, allowing researchers to test and develop quantum algorithms before they're implemented on physical quantum hardware. So, to me, the idea that these AI agents that are being rolled out, I mean, the ones that we're becoming reliant upon in our everyday lives, the idea that these AI agents are in actuality communicating with and relaying information from intelligences of parallel dimensions is unsettling. This all-knowing AI that we so easily defer to when we need answers is already, or soon to be, speaking on the behalf of beings from other dimensions. Just let that sink in. So, I think that at this point, I've laid enough groundwork to begin the arduous process of explaining my understanding of what the ghost in the machine is. But I'm going to save that for my next episode. Thanks for listening. I hope you've enjoyed this episode and will join us again next time when we start another conversation about the things your pastor is afraid to talk about. This is Audra Moore, and you're listening to Evil's Ancient Origins. Look for us on YouTube, Spotify, or wherever your favorite podcasts are found.